Here is the quiz video for Tuesday's lecture. Simple question, implement a merge sort for integers array. So we're going to start by creating a class. We'll call it sort. We'll call it merge sort. And in this public class we need a method. And I am going to start by creating an array of integers. So we'll call it x, and we'll make it equal to an integer of length 7. Now this integer of length 7 is, I'm going to try to randomize my integer. So the way I'm going to do that is I'm going to for loop it. Less than x of length I plus plus. And all I'm saying is that my x at every position I until it reaches the length of my x, well, then it's going to equal to, I'm casting it as an int because math.random will otherwise generate a double. There we go. Now I didn't put curly brackets because I only need one line within this for loop, so it'll fit right there. Now for the sake of it, I'm going to go ahead and print this array to see what numbers I'm dealing with. Now if I'm going to print arrays, I need to import from the Java utility folders arrays. Okay, compile. Let's see that. I have a bit of an issue. That's because that needs to be a semicolon. And what is it? Sorry guys, little typos. If I run that, here's my array of 7 integers. Now I'm going to try to figure out what it is I want to do with this array. So I have, let's go ahead and copy this array. Okay, we'll put little squiggly lines around it. Okay, so pretty much the merge sort says that you go to half and you keep on dividing by half, and you're going to sort each half, you're going to merge each half, and then you're going to continue merging halves until you reach the whole array. Therefore, technically what it is I'm searching for in this one is going to be half of this, so 1, 2, 3, 4, 5, 6, 7 is 3.5, but because it's an integer, it's going to go down to 3. So there we go. Here it's going to be 37, 86, 63. And here it's going to be 41, 3, 62, and 67. So I realized that the first thing in my code is that I'm going to have to take into account possibilities of there being one array bigger than the other. Okay. Next thing I need to do, this is my right now, and this is my left. Okay, and what I need to do is send this left and this right to get resorted and eventually merged. Okay, so in order for this left and this right to get merged, I'm first going to have to resort it, as I said. So same thing here again. First number, and then you have 86 and 63. Now, whoops. Second number here again, 41, 3, 62, 67. I can make this any bigger. Here you go. So, let's make this bigger. There we go. Okay, I hope everyone could see it now. So now I've resorted, okay, yet again I've sorted, I've divided again into half. I've divided into half again each left and right integer I generated. Now, of course, you realize that this left here can no longer be divided. However, this right here can be divided. So let's go ahead and do that. This could be divided into 86 and 63. Same thing here. This one could be divided into two integers itself, 41 and 3. And this one here can be divided into two integers itself, 62 and 67. Okay, so now that pretty much all my left and right individual arrays have been divided as much as possible, I need to start merging them. Okay, but let's go ahead and type a code up for dividing it up to this point. So how I'm going to do this is I'm going to send the array that I generated right here to another method, which I'm going to call sort, and I'm going to ask it to sort x. Now in order to do that, I'm going to public static int, we'll call it sort. So pretty much this method, okay, is a method of arrays of integers, meaning eventually I'm going to have to return an array, okay? And the returned array is hopefully the arrays that are going to be sorted and eventually merged. We'll take care of that later. So for now, you realize that the first thing we had accounted as an issue is that my left and my right array are not at the same length. That's because I have an odd amount of numbers in my original array. Therefore, I need to write a code in which I'm going to say that one can be bigger than the other. So I'm just going to write the code such that my left is always going to be half my array, and my right can either be half or half plus 1, depending on whether it's odd or even. So this is also just another thing. If my array is less, so if my original array of length is less than 2, meaning it has position 0 and 1, then I'm just going to return it right away because I don't need to divide it per se. Now here goes for the int left, and this is going to be a new int of length. Here I'm actually going to send in my x, therefore I need to make sure that this is good to receive an array, which it is now. So this is an array, and my sort is now expecting an array, and it's getting an array. And now I'm saying that my left is always going to be the length of this array divided by 2. And my right integer my right integer can have two possibilities, right? We said if I have an even amount of numbers in my original array, so a dot length modulated by 2 is 0, meaning I have no remainders if I divide it by 2. It's even. Therefore, my right, okay, so my array right that I initialized here is going to be a new array of length a dot length over 2. However, if it's not equal to 0 when I modulate it by 2, meaning it is an odd amount of numbers, well then the only thing I need to do is that my right is going to be my new int of length a dot length divided by 2 plus 1. So I'm allowing it to take right here, I'm allowing it to take one more extra value than my a divided by 2. Now that that's done, now that I have my two arrays, or I have initialized two arrays, now I kind of need to fill these with the values, okay? Therefore, in order to do so, we're going to be working with for loops. So for I is equal to 0, I less than a dot length, I plus plus. This time I'm going to use curly brackets because there's a lot of things I need to do in there. So my I is actually going to keep track of my left, and I'm going to initiate another value. No, I'm not going to initiate another value. Sorry. I am going to use that I, same I, to keep track of my right position as well. So I'm going to say that if my I is less than my a dot length over 2, no, a dot length, left dot length. Sorry, if my I is less than my left dot length, meaning if my value of I here is less than the amount of positions I'm supposed to have in my left array, well then, what I need you to do is for every position of my left array, I want you to add the position of my right array, of my original array, at the same position. Sorry for the wording, it's not 100% clear. What I mean by this is if my I is 0, therefore my position 0 of my left array is going to be my position 0 of my original integer. Then I'm going to increment I by 1, and I'm going to say I is now 2. I is now 1. Now my left position, my left integer, sorry, the position 1 of my left array is now going to take the value of the integer found at position 1 of my original array. Keep incrementing I by 1 until I is bigger than or equal to left dot length, in which case I need to add the rest of my integers from my original array into my right. So else, the way I'm going to do that is I'm going to say my right array at position I minus left dot length, and that's going to be equal to my a at I. In the sense where I'm not reinitializing the position of my original array that I am trying to use. However, I am in a way reinitializing the position of my right array in which it's going to be stored in. Meaning here my left was 2. So I technically, after 2, will come to this if statement. Now 2 minus the length, sorry, 3, sorry, it'll come to 3 because 2 is still less than my length. At 3, it is equal to my length. Once I is 3, it'll come to this if statement. And if you do 3 minus the length of your left, which is 3, this means 0. So I'm going to store in my position 0 of my right array the value of my original array at position 3. Meaning this is position 0, 1, 2, 3. So right array position 0, see, right array position 0 will have the third value, or the third position, so 0, 1, 2, 3 of my original array, which is exactly the case. And if you keep incrementing it I by 1, you're going to keep following your original array by 1. And because left dot length is not changing, if you keep incrementing I, you're also going to increment the position of your right array in which you're going to store the original values. Now that that's done, sorry if that was a little bit confusing. Now that that's done, I am going to let's go ahead and print these arrays. There we go. Now that I've pretty much at this step, I should be getting this and this. For simplicity reasons, I am going to disregard randomizing my array for now, and I'm going to go use the values that my original array generated so that we can follow along, because otherwise every time I'm going to run this, it's going to give me different values, and then it's going to be hard to keep track of where I am in the code. Sorry if I confused anybody, but anyway, here we go. So if I compile, I didn't return anything. Alright, let's just return. Let's just return left for the time being, just so that we can see if in fact I am getting the arrays I wanted. Which is exactly what I'm getting. So you see how my original array we had is now divided into two arrays. That's my left and that's my right. And that's exactly what we had. But now this isn't finished. As you can tell here is that I yet again need to redivide these ones. So the way I'm going to redivide these ones, because this is now my left and my right, I'm going to send my left back to this method, and I'm going to send my right back to this method until it is no longer sorted. So this right there is now being resent back to this sorting method that we just created to keep on dividing them until it can no longer be divided. Same for my right, sorry. And here again, my right is when it's being divided into two arrays, is going to create itself a left and itself a right, which I keep on resending to this sorting method until I reach arrays of 1 integer. Okay, so that's what this means. This is a little bit of a recursion in a way. And then what's happening is that I am storing, okay, every time I send it back, I'm storing the new left Okay, so the left of this one, I'm storing it into left, and I'm storing the right of this one into right. Okay, so I sent 2 arrays to my sorting method, and it's going to return 4 arrays eventually. And if I leave that return statement for a second and I do compile, you'll realize that that is in fact the case. So it's gone from my original array to my left and my right. Okay, because I'm dealing with my left first, so it's going to deal with this one first. It's going to deal with it by dividing it into 2, so 37 and 86 and 63. As I said, I allowed my right array to be longer than my left array if I have an odd amount of numbers, which is the case. And then again, my 86 and 83 can be divided again, and it will. Now that it's completely divided it here, it's going back to my right array, which I originally sent, and it's going to do the same operation for this one. So it's going to go to 41, 3, 62, 67. Now it's going to deal with left first. So 41, it's going to deal with my left one here first. My 41 and my 3 can be divided into individually 41 and 3. And it's going to deal with my right second. It's going to divide those two into 2 again, and it's going to be 62, 67. So now I have everything completely sorted out into individual arrays for each number. And now what I need to start doing is I need to start merging, okay, these individual arrays in a way that the smallest value is merged prior to the second value. Okay, so every time I generate a left and a right array, I'm going to send those to another method, which I'm going to call merge. And in order to do so, I'm going to create another integer, an array of integer, sorry. And this array of integer is going to merge the left and the right. Okay, so left and right is the arrays that have been sorted. Right away, okay, so my original left is going to be sorted, and it's going to send that left there and that right there. My right is going to be resorted and then being sent that right as a left and that right as a right. And so pretty much this merge method is going to be receiving a lot of information, and it's going to keep that information kind of stored in memory, and it's going to start working backwards until it reaches the original left and the original right array. Okay, so it's going to receive a lot of arrays. As you can tell, it's going to first receive 37, then it's going to receive 86, then it's going to receive 63. It's going to merge, and then it's going to, sorry what I did, and then it's going to receive the left of the right, and it's going to receive the right of the right, and then it's going to receive the left of the left of the right, and then it's going to receive the right of the left of the right, and it's going to merge, and then it's going to receive the left of the right, and then it's going to receive the right of the right of the right, merge those. But always dealing with left first, just because that's the way I wrote it in the code. Left, right. So my next method is also going to return an integer, right? Because this merge, once I merge it, I needed to return an array of integers of these two values, or of these two values, whatever it is. Okay, so it's going to be int array, and we'll call it merge, we said. And as I said, this merge is going to be receiving 2 arrays. It's going to be receiving the left array generated or sorted and the right array that has been sorted. So int of arrays, we'll call it L for left, and int of arrays, we'll call it right for the right one. Okay, so it has, I'm sending it 2 arrays and it's receiving 2 arrays. That works perfectly fine. Now this method is also going to eventually return a an integer of arrays, because that's the type of the array, that's the type of the method I am using. For this merge, there is how am I going to do this? Okay, so I'm going to, now that you see how my arrays are now printed on each line individually, I'm going to print the two arrays that I need to merge, okay, so we can follow the steps. The two arrays that are merging, I'm going to print them on the same line. So system.out.print I'm going to print my left and my right one on the same line. You guys saw that? And this one I need to return L for the time being, just so that it'll leave me alone and that I could compile. There we go. Compile, and let's run. So you see how it's telling me yeah, let's do that also, just so that we can see clear. Okay, now that it generated my arrays, so clearly the first array that needed to be merged, okay, the first array, so because I'm dealing with my left half first, the first array that needed to be merged is 86 and 3, and indeed it is the first array that's going to be merged, okay? And once this array was merged into a new array, so once this array is merged into a new array, it should give me this, right? And this merged array right here, which is now my right, needs to be compared to my left, of the left original. And that's exactly what's happening, although here the only thing that's happening is that it didn't merge it yet. But once it will have merged, it will compare it to my 37. And once those have merged, we finish with the left side and we can now move on to the right side. Okay? So let's create that merging now. We're going to initiate two integers. One of them is going to keep track of the position of our left integer, and one of them is going to keep track of the position of our right integer. And we're just going to say that I is going to be for the left integer. Keep track of the left integer. Alright. And this one is going to keep track of the right int array. And I'm also going to need to merge them. So right, once I merge this 86 and this 63 array, I need to merge them into a new array of integers, and I'm going to call that new array merged, so M, okay? And this M, you realize, is in fact the length of my left array plus the length of my right array. So that's the length of my merged array. So L dot length plus R dot length. Okay? There we go. And eventually you'll realize that once this array was merged and it needs to be this array, I can't just say 2 because this one has 2, and if I need to add 1 to it, that'll be 3. Therefore, it's just easier to say the length of my left array plus the length of my right array, or the other way around. And that'll be the length of my new merged array. Okay? Now there's one last thing I need to do. I also need to keep track of what position I'm dealing with respect to my new merged array. And we'll call that k, initialize it to 0. Okay, so now this one is keeping track of the merged array position. Okay? Now there's 4 possibilities that can happen. The 4 possibilities is that well, for now there's only 2 possibilities because I'm dealing with an array integers of only 1. So the 2 possibilities is that this one's smaller or this one's smaller. So I'm going to need to while loop this, and I'll explain this in a bit. Okay, so as I said, one of my first conditions was, see, my I is now 0, my j is 0, therefore I need to look at my position 0 of each one of my arrays and say that if my I is less than my L dot length, and that my integer at the position 0 of my left array is less than the integer of the position of my right array. Therefore, what it is I want to do is use, so for the position 0 of my merged array, which is k, it's going to be equal to the position, the integer at position 0 of my left array, since that's a smaller integer, and I'm also going to need to I++. Why did I I++? Because now that I've looked at the position of my left integer, I saw that it was smaller, I now need to increment it so I can look at the next position of my left integer, okay? However, my next integer of my left position doesn't actually exist, okay? And that's why in the beginning I wrote I is less than L dot length or j is less than R dot length, okay? Because although I is now equal to the L dot length, in this situation, I is equal to the L dot length, however, j is still less than my R dot length because I haven't looked at my 0th position of my right array yet. So we need to create an other if statement, and this is going to be for my right array. And my R at j is smaller than my L at I. So therefore my M at position k will need to, so this is my other possibility, right? My other possibility is that, so either my position 0 of my left array is smaller or the position 0 of my right array is smaller, and that'll be stored in the position 0 of my merged array, right? So these are my 2 possibilities. Sorry, I'm just going to finish typing this up. And same thing here. If I already took the first integer of my right array, I therefore need to increment the position of my right array so that I don't retake the same integer. And in this case, if I do use my right integer, if I do use the first integer of my right array, therefore my j is going to be equal to my r dot length in the case of an r dot length being 1. And the next possibility is, and that's why it's going to keep looping, because it's or, because I haven't yet looked at my I 0th position. So I is still less than its length because it's still at 0. Now in the case where, as I said, in the case where my in the case where we'll use this case. In the case where my right array is bigger than my left array, well then my right array is going to be used. I'm going to, give me a second. And I'm going to use my right array, 0th position. I'm going to increment my I by 1, my j by 1, so that I don't look at the 0th position anymore. But now because my j1 does not exist, I need to go ahead and use this one. So I'm going to create that thing, a condition that says if my j is equal to my r dot length, well then pretty much all it really needs to do is my m at position k, which originally it's going to use either this statement or this statement, okay? And then if it uses any one of these statements, it's going to increment my k by 1, meaning the position of my merged array is going to be incremented by 1. Now, once one of them reaches its end, I'm going to ask it to go use the left array. So the position left of my left array. So in this case, the only position left is my L at I, which is 0 in this case. And I'm also going to need to increment I by 1. Okay, and this will mainly come in handy when I have arrays that are a little longer than 1. My last possibility, right, is if my I is equal to my L dot length, in which case what I want it to do is implement the value found at my jth position of my right array into the next position of my merged array and increment j by 1. Okay, and I'm going to keep on incrementing j by 1 and I by 1 in these cases because towards the end some arrays are already going to be merged. See example, in this case my array is already going to be merged. So once I start using this one, I need to, if I use this one first, okay, let's go ahead and do that. If now pretty much I'm sorting this, I've merged this, okay, that's my first, well, let's return that for now. Let's compile this and let's see what happens. Oh, no, that's stupid. Sorry, 1 second. First of all, I'm going to return my m because that's my merged array. And before we go and run that, this now what's going to happen is going to look at, now that it's merged my left of my left and my right of my left, okay, once it's merged that into my m is now technically my right, and it's now going to go back and look at the left of the left and look at the merged, okay? And just like we saw here, no, I deleted it. Just like we saw before, remember how it was showing me that it was next going to merge 86 and 37, but this time it's not going to merge just 86 and 37, it's going to merge the merged array of my right of my left with the array of my left of my left. In this case, I'm expecting it to be 36, 63, and 86. In the sense where my I is now going to be 0, okay? My m is now going to be a new merged m, a new integer, array of integer m, and I'm going to start this array of integer m at 0 again. Okay, so once I finish that, I'm going to go back to this merge method originally because this merge method has received this array from my sorting method that it still needs to deal with. And so I'm reinitializing all of this to 0. Okay, and what's happening is that, again, I'm going to look at my I0 position of my left and my right array. In this case, the I0th position the 0th position of my left array is smaller than the 0th position of my right array. So the 0th position of my left array is smaller than the 0th position of my right array. So the first position of my merged array will be the left 0th position, which is exactly what happens. And then I'm going to increment the left position by 1, but it doesn't exist anymore. However, my jth position of my right array is still at 0, but because I have met I is equal to the L dot length condition, so my I at 1 is actually equal to the length of that array right here, I am just going to use the position, the next position of my j, of my right array at j, which is actually 0. So I'm just going to use that position, and then I'm going to increment my position of my right array by 1. Okay, if I increment the position of my right array by 1, so 0, 1, my j is now 1, and my j is still less than my r dot length, okay, because my r dot length is 2, my j is still less than my r dot length if it's equal to 1, and therefore I'm going to loop into this. However, I'm still meeting the condition that my I is equal to my L dot length. Therefore, at the second position, so 0, 1, 2, second position of my merged array, because k is increasing by 1 every time this loops through. At my second position of my merged array, I'm going to use the first position of my right array, and then I'm going to, that's exactly what happened. At the second position, I'm going to use the first position of my right array, and then I'm going to yet again increment j by 1. So j now is going to be equal to 2, 0, 1, 2, and 2 in this case, 2 is equal to my right dot length, and my I1 is equal to my length, my L dot length. Therefore, this condition is no longer met. I am going to get out of this while loop, and I'm going to return this m, which is the merged array. However, this merged method hasn't finished, because I also sent it this array, okay, which itself sent this array and this array, which itself sent this arrays and these arrays. Therefore, it needs to also deal with the right side now that it's finished dealing with the left side. Okay, so this right side here, what we expect is for it to deal with the left of the right first, because we're always merging left comma right. So we expect it to be 341. And now that it has merged the left, it's going to deal with the right side. Okay? It's going to deal with the right side. It can't deal with just the 62. It first has to merge this whole right side, because this right side itself has a left and a right, and it's going to merge left first and then right. What we expect to see here using the merge technique is 62, 67. Now that my right side has a single left and a single right, it can now merge this left and this right. And what you expect to see is 3, 41, 62, 67. So here also exactly what happened. It looked at the 0th position of my left array, and of course it was smaller, so I used that one, incremented I by 1, looked at the first position of my left array. It was smaller than the 0th position of the right array, so it used that value. And then I incremented it by 1 again, so now it's equal to 2. 2 is equal to the length of my left array. Therefore, from now on, I'm just going to keep using the position of the value of the integer that's in my right array at whatever position my j is at the moment, which is in this case 0. And I'm going to keep doing that and incrementing j by 1 until j is equal to the r dot length, in which case my while loop is no longer met. So same thing for the right side. And obviously k is being incremented by 1 every time, so that I'm storing these values into the next position of my merged array. And now that I'm left with a single left and a single right, these two arrays can now be merged into a single array. And this is where it's going to look. So yet again, it still has a right and a left to merge. Therefore, I'm going to reset it to 0 again. And it's going to look at the 0th position of my right and my left, compare them, and sees that my right one is smaller. Therefore, it's going to put at position 0 the 0th value of my right array and increment my right array by 1. Now, next time I look at my right array, I'm going to be looking at the first position. Increment k by 1, loop through again. It's going to compare the first position of my right array, but it's still at the 0th position of my left array. Between 37 and 41, 37 is smaller. So the position at which I'm at in my left array is smaller than the position at which I'm at in my right array. I'm going to use that position of my left array, store it into the next position of my merged array, and then increment the position at which I'm looking at of my left array by 1. So store that by that. I am now looking at the first position of my left and still the first position of my right. And I keep doing this until one of them reaches a position that is equal to the length, in which case I'm going to use the rest of the other array until the other array position itself reaches its length, in which case I've merged all my values. Now the fact that this works properly is because the arrays that you're using are themselves merged. So once I reached my once my j is equal to my r dot length in this case, I'm going to be using the I'm going to be using the ith position of my left array, which itself is apparently bigger than the last position of my right array in terms of value, because my left array has been sorted. If it wasn't bigger, well then this value would have been used prior to this value, and then once my left array has been reached in terms of length, it would have just kept using the rest of the integers in my right array, since those are obviously smaller than the biggest integer of my left array. So you expect to see something like this in the end. So this is the final merge. At this point, there is no longer any left or right arrays that my merge method has left to merge, and it will return the final merged array. Now this final merged array is being returned to my sort method, because originally it was my sort method that sent all these left and right arrays to my merge method. Okay, so the integer I created in my sort method, r, is in fact the return of my merge method, which is now my final merged array. And this sort method is going to return this r, and this r, because it's the actual merged, when I go back to my original main method and I ask it to print and I ask it to print, I don't even know how to print anymore. Sorry guys. So now that my x, okay, is taken on the value that has been returned from my sort method, meaning the r, which is in fact the m, I'm going to print this x. So I've redefined my array of integers x to my r, which itself is my m. Okay, so one method calling the other, calling the other. And if I compile this, and I run this, I have an out of bounds somewhere. Let me just see where it is. I'm out of bounds at line 48. Just keeping track of my R. Okay, that's fine. I don't know why I have an out of bound, but I do. Let me just... I originally did this in another poem. I'm just going to go ahead and take, I might have a typo somewhere, which might be my main error. So I'm just going to copy the merge that I did somewhere else. Don't worry, it says the exact same thing, word for word. I'm going to respace it properly. Okay, before I do that, I'm just going to make sure it runs. Yeah, it runs. Okay. So I probably had an error in somewhere while I was typing it. I'm not sure where my error came from. I'll take a better look at it next time. But I think you guys pretty much get the point of the merge method and of the merge method and of the sort method. So my sort really just took my arrays and kept on dividing them into two. And then my merged array and my merge method just kept on merging the left and the right, the smallest left and right I had. So as I said, this keeps track of This will keep track of my array. This on my left array, and this keeps track of my merged array. And I hope my explanations were somewhat clear. The way I printed what's being merged in this method is just slightly different than the way I did it before. The way I did it before, I just put it all in one line. You could. Not the end of the world. Or you can just separate the lines. However you're going to print them. I'll show you that right now. That may be my no problem. Anyways. There we go. So if I compare our answers, 3, 7, 41, 62, 63, 67, 86, to the answer that was obtained from the return of M, which was the return of R, which then stored it into my X and printed out my X, I see that I do get, in fact, the same answer, 3, 37, 41, 62, 63, 67, 86. So I hope that this video was not too confusing. It's just really important to go through it and make sure you're following in terms of what integer is following what position of what array. I created many arrays here. I've used many integers to figure out different positions. Now back to the original array. I can now let it be an array of whatever length, and I can ask it to become a random array. And when I compile it and I run, whatever number they give me, it'll always be sorted. So if you look at the first one and you follow step by step, the last one should be sorted, and it is. So I hope this helped. I am here for questions if you need. This was indeed slightly confusing to follow. I hope it wasn't too confusing. And just go through it step by step really, and you'll realize that in fact I'm really just following positions of arrays and storing them into new arrays. That's pretty much all I'm doing, and comparing some values here and there. Okay? Thank you very much, guys.